Hello and welcome to another riveting video about Algebra 1. This is Unit 4, this is Section 5, and this is Solving Systems of Linear Equalities. So what I want to do first is, review a linear inequality. A linear inequality is something that is where you have an inequality involving two variables. Okay? And when you have systems of linear inequalities, that means you have multiple inequalities. Okay? So we're going to look at where you have more than one inequality and seeing where there are solutions that would satisfy both of them. So the difference between the last section and the other one is that we have two of these inequalities, okay? So when you see here, you have this inequality y is greater than or equal to 1/2 x plus 1. That's this inequality here. And the y values are larger than that line, okay? And so this is where we are, any point in the shaded region satisfies a solution to this inequality. Okay, same thing over here with the blue one. Okay, this is y is less than negative 1x plus 3. And so when you have this, what we want to find is the part where they both intersect. So the solution to the system, is where both areas intersect. Okay, so let's just go ahead and jump right into this and get started here. And it's going to be the same thing as we did on the last one, just that we just want to make sure that we do both of them and graph where the solutions are for both. So let's first look at y is greater than or equal to negative x over 3. So y is greater than or equal to negative x over 3 and then minus 2. Okay, and first thing I'm going to do is rewrite this so it's a little bit easier. Y is greater than or equal to negative 1/3 x minus 2. The reason I did that is to identify my slope as negative 1/3 and then my y-intercept as negative 2. Okay, so I'm going to come over here and plot the y-intercept of negative 2 here, and then a slope of negative 1/3. So down 1 to the right 3, down 1 to the right 3. Okay, up 1 to the left 3, up 1 to the left 3, and so on. Okay, now because my line is greater than or equal to, we're going to have a solid line. Okay, and so I'm going to connect all of these points with a line. Okay, and we know that y is greater than or equal to all of this. So I want to test a point. Okay, I want to test the point 0, 0 in this inequality. So I'm going to plug in 0 for y is greater than or equal to negative 1/3 times 0 and then minus 2. So negative 1/3 times 0 is just going to give me 0. So we get 0 is greater than or equal to negative 2. So because I have that, this is a true statement. So wherever I have that point, 0, 0, I'm going to shade where it's true. Okay, and so I'm going to come here and shade this region in, okay, to know that we're above that line. So now on the same graph, all right, I want to do the same thing, but for y is less than 2/5 x plus 3. So I'm going to do the same thing. So y is, less than 2/5 x. Y is less than 2/5 x, and then plus 3. Okay, make sure, okay, plus 3. All right, so I know that my slope m is equal to 2/5, and my y-intercept is equal to positive 3. So I'm going to plot 3 first, okay, right there. And then I want to go up 2 and to the left 5. So up 2 and then over 1, 2, 3, 4, 5. Okay, we do the same thing, going to go down 2 and then to the left 5. All right, and because my line, because we're just strictly greater than, this is going to be a dashed line, okay? I'm sorry, strictly less than. So I'm going to come here and just kind of put these points in here. All right. And so then what I'm going to do is I'm going to test the point 0, 0. Okay, test the same point, test 0, 0. Okay, and so what I have here, if I plug that in, I'm going to get 0 is less than 2/5 times 0 and then plus 3. So I end up getting that 0 is less than positive 3, which is also true. So because it's true where that point was, I'm going to shade below. Okay, so where I have this point here, okay, I then shade below. All right, and this is where it kind of gets a little interesting. But I'm going to shade all of this area here. Okay, and we want to think about where do our areas intersect. Okay, and that is our solution set. That's the area that we're looking for. So it's above this line, but below this line. And it's only within this little triangle of fun that we have all that put together. All right, so that's what we're looking for, is the area in which our shaded region is combined. Okay, so that's the idea. All right. Okay, so let's jump in and just do this again. Do a couple of examples. Let's first do this one where you've got y is greater than 6 plus 3/4 x. And this is written a little bit differently. I want you to notice that, I'm going to color this one in red. I'll do this one in blue. Okay, so the one in red, I need to find my slope. And my slope is the number that's in front of the x. It's not always going to be the first term, but it's always the coefficient in front of the x. So my slope is positive 3/4, and my y-intercept is 6. Okay, so let's go ahead, and this is going to be a dashed line. Okay, dashed, because we're strictly just greater than. Okay, we're not equal to that. So slope of 3/4, y-intercept of 6. So here I'm going to plot 6, and then we're going to go down 3 and over 4. So I'm going to go down 3, here's to 3, and then over 4, down 3 and over 4. I'm going to go up 3 and over 4. And so I just keep getting this dashed line. Okay. All right, and that's that. Okay, there's that line. And then we want to test a point. All right, I'm going to test the point 0, 0. So I'm going to test the point 0, 0. And we get that 0 is greater than 6 plus 3/4 times 0. Okay, this part just turns to 0, so you get that 0 is less than 6. And this is a false statement. Okay, so because that's a false statement, I'm going to shade in the opposite direction. Okay, so I'm going to shade up here. All right, that is the area that does not contain the point 0, 0, and so that's where I'm going to shade. All right, now the next thing I'm going to do is take a look at this next one and identify my slope. Ooh, this is interesting, as 3/4. Okay, and then my y-intercept. So we have the same slope, different y-intercept of -2. So I'm going to do the same thing over here, but this is a solid line. Okay. Because we are including the equal to portion, we have a solid line. So -2 is here, and then I'm going to go up 3 over 4, up 3 again over 4, and down 3 over 4, down 3 over 4. Okay, and I'm going to color that in. All right, so now we want to test 0, 0 again. Okay, it's above the line. So we'll test 0, 0. So if we test the point 0, 0, then we get this. We get 0 is less than or equal to 3/4 times 0, and then -2. So then we get that 0 is less than or equal to -2, and this is also a false statement. Okay, so then because that 0, 0 is here, I need to shade in the opposite direction. Okay, and so what we notice, okay, once I shade strictly below this line, okay, we can assume that there is no solution to the system. Okay, so there's no solution to the system. Okay, all right, so now let's take a look at the next one. All right, over here, I'm going to do this one in red. okay? And again, it's kind of hard to see, but here's my slope, here's my y-intercept, even though they're kind of backwards. The 2 is in front of the x. It's the coefficient, okay? So my slope m is equal to 2. My y-intercept is equal to negative 2/3, okay? And so then there's that. I'm going to use a dashed line because we're strictly just let y is less than that, so we're doing dashed, okay? So let's go ahead and graph that real quick. So we've got a y-intercept of negative 2/3 and a slope of 2. So negative 2/3 is down here, and then a slope of 2. So I'm going to go up 1, 2 over 1, up 1, 2 over 1. It's kind of hard to see, but just because looks like I'm 1/3 away here, when I go up 1, that unit is here, and then up 2, that unit's right here. Okay, same thing down here. I'm going to go down 2 units, and then over 1, okay, down 2 units, and down 2 units, there we go, okay, and then over 1, all right, and that's the idea. So we have this dashed line that's going up in this direction. Doesn't have to be perfect, but just get the idea, okay? And so then we want to test the point 0, 0. So we're going to test the point 0, 0, and if I test that, I get 0 is less than negative 2/3 plus 2 times 0. So that goes away, and so I get 0 is less than negative 2/3, which is a false statement. Okay, so therefore, I'm not going to shade where there's a 0. The 0 is right here, so I'm going to make sure that I shade in the opposite direction and shade over on this right side. Okay, this is really fun. I enjoy doing this. Okay, the other one, let's take a look here. Now this one I'm going to do in blue. My slope, m, is equal to negative 2/5, and my y-intercept is equal to negative 3. Okay, again, this is going to be a dashed line because there's no equal sign underneath it. So we start our value at negative 3, and we go up, what is it? Negative 2/5, so I'm going to go down 2 to the right 5 and plot another point here, and then up 2 and to the left 5, plot that point here. And again, this is going to be dashed. So I'm going to come through here with a dashed line. And then I want to test the point 0, 0. Okay, so we're going to test the point 0, 0. And I'm going to get 0 is greater than negative 2/5 times 0 and then minus 3. So then that goes to 0. So we get 0 is greater than negative 3. This is a true statement. Okay, so I'm going to shade where it was true and above that line. So let me come here. Let me get in here, and we're going to shade above because that's where 0, 0 was. And now we have an intersection of areas. So I do want to highlight that, and that's this little area here, which is our solution set to the system, okay? So any point that's inside of this area here will satisfy both systems of equations, and that's what we're looking for, okay? Let's go ahead. I'm going to go ahead and just stop there, guys. Kind of a reasonably long video. You guys can try this one on your own. I would solve this for y. Okay, if you're going to graph that and do that. So either way, however you want to do it, that's fine. But I'll kind of leave you at that. So hope you enjoyed this video. I had a lot of fun making it, and we'll see you soon. Thanks. Bye.